Good morning and good afternoon, everyone. We're looking so forward to this discussion here today. My name is Josh Eddy, and I am the Director of the California Department of Food and Agriculture, International kind of Coordinator, and we're very pleased to be having our first collaboration with California and the Western Cape, focusing on climate-smart agriculture. As you know, California and the Western Cape are very special places. We are 2 of 5 Mediterranean regions in the world that produce a wide variety of agricultural products that are only grown in certain places, special places, and our locations are definitely those. The importance of climate-smart ag in terms of addressing the challenges of not only drought and wildfires is something that both California and the Western Cape have experienced. And in our discussion today, which we're so looking forward to, focuses on agricultural water use efficiency in both California and South Africa. Today, we have a wide variety of speakers, not only from the Department of Agriculture, but from the California Department of Water Resources, our friends in the Western Cape government, the Department of Agriculture, Department of Environmental Affairs, as well as Western Cape Emergency Response. Some of the topics that we'll be focusing on include a drought overview for both California and Western Cape. We'll talk about water use efficiency in California and some of the governance programs we have in place to help assist us in meeting our future needs. We'll hear about the ecological infrastructure framework within the Western Cape and how they are addressing those changes as we move forward in drought as well. And lastly, we'll hear from emergency management in the Western Cape and trying to do preparedness for day 0, which we all heard in terms of lack of water supply for the city of the Western Cape Town. So again, thank you so much for participating today. We look forward to some great dialogue and some great introductions. I'd like to turn this over to my colleague and friend, Dirk Trusky, with the Western Cape Department of Agriculture for some remarks as well. Dirk?
Good afternoon from our side. Good morning on your side. It is for us very exciting to be on over this vast area, being participating in this particular event. Josh indicated initially that the Western Cape and California has got a similar climate, and for that reason we share similar problems in terms of drought, in terms of floods, in terms of fires. And we're of the opinion that there's a lot that we can learn between these 2 regions, and together we can build synergy and be stronger on the other side. So welcome to everybody, and I trust that this next 2 hours will be worth the while and will be very informative to everybody participating. Josh, over to you.
Perfect, thank you, Dirk. Just as kind of a reminder for everyone, for our speakers, if you're not currently speaking, please make sure your mics are muted. For attendees, we have, again, a number of presentations here today. And so what we're going to do is take questions at the end for our overall discussion. So if you have questions, please be sure to put those into the chat function or the question function on your dashboard. So you can enter those questions there, and as we proceed to the end of our session, we'll be able to address each of those questions kind of moving forward. And again, we look forward to this discussion. And with that, we'll begin our first presentation. So, Dirk, would you like to introduce our speakers?
The first presentation will be a joint presentation between Ms. Asia Peterson. She's the Program Manager for Sustainable Resource Management in the Western Cape Department of Agriculture, where she's, amongst other things, responsible for water and irrigation engineering support and disaster risk management in the Western Cape. The other speaker will be Mr. Louw Pienaar. He's an agricultural economist specializing in macro and resource economics, and he has recently done various economic impact assessments for the department. And one of these impact assessments include research on the impact of the drought on the agricultural sector in the Western Cape. Asia and Louw, over to you.
Good morning and good afternoon. I didn't think I would say that both in one sentence, but definitely I am. So I'm Josh, if you could just my presentation. So I'll basically give an overview of irrigation within the Western Cape, and particularly the impact it had on the drought had on our irrigation allocation during the drought that we've had. Next. So for us in the Western Cape, our rainfall distribution across the province varies from 100 millimeters to 1,900 millimeters per annum. So you can see there's a great variance in the rainfall spread across the province. And at the same time, we've got a distribution of our rainfall in terms of when it falls. So we get in most of our irrigation areas, our rain is in winter, which is during May and September. And then of course in our very dry, arid to semi-arid areas, we've got summer storms during March, April to October, November. And then of course we've got an area where mostly rain-fed agriculture takes place. That's where we have year-round rainfall. Next slide. But what makes the Western Cape so unique is the fact that our water requirement during winter is only 25%, but we receive 90% of our rain during winter. And in summer, when our need for water is 75%, we only have 10% rainfall during summer. Next slide. And can you go back a bit? And what makes the Western Cape unique is that we basically need to store our runoff water that we receive in winter so that we can use it in summer. And the Drought is the biggest dam in the Western Cape. The annual yield is 490 million cubes per annum. And I'm going to use this dam to illustrate the challenges that we had, or our limited resource during the drought, and the kind of water restrictions that was placed, particularly in the agriculture sector during this period. Next. So in September 27, we were already in our third year of the drought, and you'll see the Drought dam levels were at 28%. And at that stage, agriculture was restricted 60% of the allocated water use, which meant that they only had available 40% for irrigation. Next. And you can see on the image how dry it had been in January 2018. At that stage, the dam was only 12% full. We went in April, our dam levels went to 10% full, or the Drought was 10% full in April 2018. Next. That winter we had a good rainfall, and by September 2018, our dam level was at 52%. And our restrictions were 10% for the agriculture sector. Next. Last year, our dam was at 72% with 0% restrictions for the agriculture sector. Next. And this year, as of 5 days ago, we're on 100% full capacity for the Drought. Our irrigation season started the 1st of October, and it goes to the end of April, and it's anticipated that we will have 0% restrictions on the agriculture sector as well. Next. So looking at the drought is not our only disaster. We've got many in the last 7 years. You can see that we've had an increase in the number of disasters happening within the same year, but we've also had an increase in the intensity of these disasters. And you can see for the drought, we're still in the 6th year of our drought. Although in our irrigation areas, the drought has been broken, but many other areas within the province, there's still a drought that is existing. And can we go to the next? So based on disasters being very real, with climate change, it increases and its frequency and intensity. What do we do to build drought resilience within our province? And I'll just share a few of the interventions that we have implemented to date. Next. So one of our big projects is, it's called the Fruit Loop project. And there we use remote sensing or satellite imagery to manage the water application to irrigation during the irrigation season. And what it basically tells the farmer is the soil moisture content in the soil to determine what the application should be. So ultimately, it's using our water more efficiency, and it can be seen as a water demand management tool. And most farmers have indicated that they save water, and in some cases, we even have farmers reporting up to 30% of the normal water use, a reduction in that. Next. We've also invested in canal maintenance. You'll see during the height of the drought in October 2017, one of our canals was filled with sand, which had a direct impact on the ability of the dam downstream to be filled. So we've invested in clearing the sand and in clearing debris, and by 18 months later, we could see that there was more water flowing into the dam, which had a significant impact on our yields in the end. Next slide. Invasive alien plants is one of the big challenges for our water security in our province, and we've got very water thirsty plants, or the invasive aliens that we have is very water thirsty. So it has direct impact on available water availability and also the yield of our dams. So what we're doing is we're basically removing the invasive aliens along our river water resources and ensuring that we increase our yield and hence have more water security in the agriculture sector and of course domestic and industry as well. So the top picture shows you the level of alien infestation in the river course, and down a few months later, 3 months later, you can see that the stream is completely divorced from or removed. All aliens have been removed in that area. Next slide. Can I have the next slide? One of our other big infrastructure investments is a green engineering solutions. So what we've done is we build river protection works. So this year is a gabions with a weir, and we've seen with floods that many of our productive lands are taken away by the floods, and it also diverts the river flow. So to slow down the river flow and also to ensure that we don't lose any further productive agricultural land, we build these structures that will slow it down, but also in the end improve our water security for agriculture. Next slide. I think that's the end. Thank you. I'll hand over to Lo.
Great. Thank you very much, Asha, and thanks everyone for joining. It's a great privilege to be sharing with you some of the lessons we've learned in terms of the drought and specifically related to sort of irrigated agriculture. And so today I would like to really just tell you what we've learned in the last 2-3 years of really bad droughts. And since I'm an agriculture economist, to me it was also a learning curve to try and understand what impact does the lack of irrigation resources mean for the agricultural economy. So you can start with the first slide. And then, so basically just the talking points, I'll talk about our dependence on water from the agriculture sector, and then I'll talk about the economic impact assessment that we've done. And then I'll show you also a severe case study of a specific area within our province that was the worst hit by the drought. And then I'll share some concluding remarks. Right, so I think once we need to start, obviously we are a water scarce area, but I think it's got an animation there, but the one at the back really shows what is the kind of water availability for South Africa compared to some other countries. And basically what we see is that South Africa comparatively have got a very low water per capita per annum, and then also very low rainfall averages compared to Brazil, Australia, the US, France, Botswana, India. So we're starting from a point where we are extremely restricted in terms of our water availability as a country. But then, like Asha said, also we've got we've got a winter rainfall region, which means we need to store a lot of the water which we will need then in the summer. Now, what you'll see on the bar charts there is our 4 main water management areas: the Breede, Gouritz, Olifantsdoring, and the Berg River. And the yellow parts of those pie charts suggest the water supply that's used by urban users in cities. So that would be your drinking water that will go into people's households. And then the blue bar would be that will be used for irrigated agriculture. Now, our biggest water management area is the one on the right, the Berg River. And what we saw in the drought, when we had such little water available, there became a very big challenge between allocating and using the competing interest between agriculture and then urban use. Next slide. And what we then see is that this is the long-term trend for our inflows. So what will directly influence the Cape Town Dam inflows will be obviously the rainfall that we receive in our catchment areas. And what you can see here, as far back as 1928, the 2015, 16, and 17 were really outlier years, and they were all very low rainfall years, and that meant that our dam levels went really down. Just go one slide back, please. So this slide, and you can go one forward. Thanks, Josh. And so basically what this really weak rainfall that we had consecutively since 2015 has meant that our dam levels, which were full for 4 or 5 years in the previous decade, meant that over a space of 3 years, our dam percentage declined to a point where it was close to 18% in February 2018. And like Asha showed you now, we did get some good rains for the past 2-3 years. And now for the first time in 3 years, we've got 100% dam levels for our major dams. Right, in the next slide, I'd like to comment just on what has been the economic impact and also talking about water restrictions. Asha shared with you that we had a 60% cut, and that slide just gives you the timeline for when we started, but it didn't just start in December, it got to 50%, and then basically from December 2017, we had a 60% cut in allocated water to the agri sector, which means if you were a farmer with fruit, then you only had 40% of your normal allocation. So for many people, they only had between 2,000 and 3,000 cubes per hectare to irrigate during the season. Now, the next slide would show you some of the calculations that we made during that time to try and estimate what would be the impact to the economy. And this was specifically just looking at our irrigated area. Now, just to get a sense, if you take the total Western Cape farm income and you divide it into the different agricultural industries, we have about $1.5 billion in gross farm income, and 41% of that is from horticulture. So there already you can see that a big impact on the horticulture sector would obviously have a very big impact in our wider agricultural sector. And we've got about 4,400 irrigation farming units, and those farming units supply about 107,000 jobs to farm workers. And then you can see there the area of irrigated. We've got quite a big wine grape area under production. Then we've got about 30,000 hectares of apples and pears, quite a bit of vegetables grown, and then stone fruit, citrus, table grapes, and then a few other flowers, berries, and nuts. So then the question is then, what was the impact of this drought? You know, it's people were asking how severe was this drought, and we often say it's probably the worst drought in recorded history in our province. But then looking at the economic impact on the next slide, we kind of get a sense of what the impact was, both for job losses and then also on farm income. Now, again, just remember there we had a 60% less water allocated to the sector, and that, in a sense, meant that the production dropped by 20% on average, but some areas actually had a higher decline. But that meant that we lost about 6 billion rand in terms of farm income for that year, and around 30,000 job losses. Next slide. The next slide will just show you what that meant for our agricultural GDP. This is the nominal value in rand terms over this period, and clearly you can see from 2015-16 the sudden drop in the annual change in our agricultural GDP, dropping from about 20% positive growth the year before in 2015, and then 3 or 4 consecutive years close to -10 decline. So that had a massive impact on our agri sector. Next slide shows the job losses, and our projection was quite close. Over that period, we saw some 30,000 jobs being lost, but we also see now, since we've got improved water in our dams, that the jobs are slowly coming back, but it will also take some time. And then the next slide. You can actually skip this slide, but this was an area in the Olifants River where we didn't have 60% cut in water. We had an 83% cut in this region, and this region has about 12,000 hectares of irrigated area planted. And you can just flip to the next slide to see what was the impact of, next slide, what was the impact of this area that only received 20% of their water allocation. And there you can see with 83% cut in their water, the change in production was 44% in that specific year, and a net income loss of 200 million. Just the final slide as I conclude is to say it's not only the primary sector that we saw was heavily impacted by the drought, but it's also across the value chain. So this is just a value chain map for that area. And even though the primary farming sector lost 200 million in income, look at the declines in the input sector. Because farmers did not have the irrigated water, they used 30% less fertilizer, 27% less chemicals and sprays. They reduced their labor supply by 22%, and a lot of the area didn't use any seeds for vegetables because there just wasn't any water available. And so basically, just in concluding, what we see and lessons we've learned from this drought over the last 2-3 years, just the last slide there, Josh, is that we've certainly learned a lot, and the drought had major impact in our irrigated area. But what we also see is that our agriculture sector was quite resilient and is bouncing back now. And then obviously also the drought has wider impacts on our agricultural and then the wider economy. And the impacts of those job losses has been massive for people's livelihoods. But then again, we also learned quite a bit in this process, and we're happy to share some more thoughts on that in the question and answer session. Thank you very much.
Well, thank you very much for the presentation. And now I'd like to have the pleasure of introducing a good friend, Jeannie Jones, with the California Department of Water Resources. She serves as kind of the interstate resources manager for our Department of Water Resources. And Jeannie has a great history in terms of water policy and water systems here in the state, and is one of our foremost experts on the drought. So Janine, I'd like to turn the presentation over to you.
Okay, thank you, Josh. Good morning or good afternoon, everyone, as the case may be. Just for orientation purposes, this is a picture of our California aqueduct traversing its way through the farmland in the San Joaquin Valley. Now, here we have a map of the U.S. showing precipitation, annual precipitation. California on the west coast. Note that we have a very high spatial variability in our precipitation because we have varied topography. We also have a large variation in supply from year to year, as well as precipitation throughout the year. On average, statewide, 75% of our precipitation is in our winter months from November through March, and 50% is in just 3 months, December, January, February, and we have a summer season, which is essentially the dry season. Next slide, please. So just some numbers for sake of giving you a ballpark idea. Most important fact about California water management is that most of the water supply occurs where the demands are not. Next slide, please. Now, if we look at this map, in a previous slide, I had said that 70% of the demand is in Southern California, while 70% of the supply is in Northern California. If you visualize a horizontal line drawn through the city of Sacramento on this map, that's roughly your dividing line for the 70% metric. So in response to this, California very early on developed an extensive system of water infrastructure, dams, canals, pipelines, etc., to move water from where it occurred to where it was needed. And our own California State Water Project facilities, which are shown in red on this slide, move water all the way from Northern California down into Southern California, where through local infrastructure, it actually makes it all the way down to the city of San Diego. Also important to note on this map that if you were to draw a horizontal line roughly through the Los Angeles area, about half of the state's population is south of that line. So our population is very concentrated in Southern California. And if you look at the large green valley that runs roughly northeast or northwest southeast throughout much of the state, that is our Great Central Valley, which is the home to about 80% of the state's agricultural production, and also obviously a lot of agricultural water use. Next slide, please. Groundwater is also a very important part of our water supply, and you'll see that the Great Central Valley that I just mentioned is highlighted as one of our major groundwater basins. The blue shaded areas are our major groundwater basins, and groundwater is a very important supply not only in normal water years, but very important in drought, especially for agriculture, because when surface water supplies are depleted, people turn to groundwater. Next slide, please. Just a few factoids. State population's about 40 million people. We're obviously a very important agricultural production state. And we also have a lot of fish and wildlife species that have special protected status, which in some cases, such as with anadromous fish like salmon, affects management of water infrastructure. Next slide, please. So moving on to drought now. California is no stranger to drought. We have reconstructed paleoclimate for California going back 1,000 years or so, for the Colorado River going back even longer than that, pointing out that drought is a recurrent and expected feature of our climate. And frankly, there are droughts much more severe in the paleoclimate record than we have experienced in our short period of recorded history. Next slide, please. So our most significant droughts in our recorded period of history are shown in this slide. The ones highlighted in red are the most severe ones. In the historical record, our worst dry conditions actually occurred in the 1920s and 1930s, where we had roughly over a decade, actually, of generally prolonged dry conditions with an occasional wet year interspersed. In more recent years, our longest drought was the 6-year drought of 1987 to 92, and most recently we had a 5-year drought in 2012 to 2016, and I'll be talking a little bit more about that one. Next slide, please. So fortunately, we have lots of tools for managing drought. Most importantly is the fact that we have this unparalleled system of water infrastructure that allows us to move water around from place to place throughout very long distances, as far away as the Colorado River Basin from the Rocky Mountains for Southern California. Much of the state does have access to good groundwater resources. We have a long history and tradition of planning for drought and supporting conservation activities. And during drought, because we do have this extensive system of infrastructure, it really facilitates many response actions such as water transfers. Next slide, please. So, we know that drought is a normal part of our hydrologic cycle. It's also very clear that drought impacts are not monolithic. Different sectors and different parts of the state are affected differently. And frankly, our greatest drought impacts are related to unmanaged water uses. And by unmanaged, I mean circumstances where simply you have precipitation falling as rain and that's it. You have no tools such as reservoirs, canals, wells, irrigation to manage it. And therefore in the agricultural sector, it's rangelands grazing that is affected. And actually, we do a pretty darn good job of managing drought, big picture, from a water supply perspective in California, because the greatest economics of drought have not been affected with, associated with managed systems. They have been associated with unmanaged systems, and especially it's been wildfire. Next slide, please. So, not our first rodeo with drought. We have a very good understanding of who is affected in terms of sector and category. The health and safety impacts are shown in red. With respect to managed systems, really our main impact on health and safety is very small water systems in areas with unreliable water supply, typically systems on fractured rock groundwater that might only serve 100 connections or so, certainly not the major cities. But really, wildfire, and I'll come back to this again in my concluding slide, our biggest impact by far in unmanaged systems is catastrophic wildfire, something that we are seeing increasing. Next slide, please. So, we've had plenty of experience with what's happened in our past droughts. And we know that with respect to agriculture, for example, it is very much a function of how senior are your water rights, how good is your water source. And what we saw during the drought and previous droughts as well is that for people whose surface supplies are impacted, many of them have the ability to turn to groundwater to make up cutbacks. For example, one large area in the southern part of our Central Valley that was served by the Federal Water Project in California's last drought had 0 irrigation supplies of surface water for 2 years in a row. Growers were able to maintain their permanent plantings, a lot of orchard and vineyard in that area, by turning to groundwater, although excessive pumping of groundwater does in turn have impacts. But the other big thing to keep in mind with respect to agriculture is that crop markets also play a role when you think about what are the economic impacts of drought, because if prices are good in international markets, that may offset some of the losses associated with diminished water supplies. And worth pointing out that California's farmers have been very adept at going to higher value plantings to make up for the increased cost of water management and water scarcity. Next slide, please. So, and this is my final slide, just to point out something that we really saw very dramatically in our last drought. We had our 2 record warmest years in terms of statewide average temperatures. We had record low snowpack. Wildfire risk and wildfires escalated dramatically. There was extensive ecosystem damage in terms of headwaters forest areas, widespread tree mortality, leaving a lot of dead vegetation on the landscape, which continues to be a wildfire hazard even now. And California is once again this year setting new records for wildfire. So we are really seeing the impacts of long-term drought on the greater landscape, aside from just within the water supply world. So Josh, this is where I wrap up now. Thank you.
Janine, thank you so much, and thank you for also ending on a beautiful picture of California as well. That's great. Thank you. Our next speaker is another great friend from the California Department of Water Resources, Mr. Christopher Tersnell, who is the Deputy Director as part of the executive team for the Department of Water Resources and oversees kind of integrated watershed management. So Chris, I'd like to turn the presentation over to you.
Wonderful. Thanks a lot, Josh. And good morning and good evening to our friends from across the earth. It's a pleasure to have the opportunity to talk about some of California's unique systems, challenges, and to really see, but also mostly just feel a lot of the similarities, so many similarities between our experiences with water management. So I'm going to bend the rules a little bit here. I was asked to talk about water use efficiency. And what I'd actually like to talk about is, I think, a different type of water use efficiency than we usually think about when we say WUI or water use efficiency. So often that brings to mind the sense of end user efficiency, drip irrigation, satellite driven, evapotranspiration, information driving decisions on when and where to irrigate, things along those lines. All very important, and we're going to have plenty of robust conversation about those topics, I presume, in coming presentations. But what I wanted to talk about here was really about watershed efficiency. How are we dealing with the big picture efficiency systems? When we look at our water systems on the grand scale, are we squeezing every drop we can out of them? Are we coordinating our systems to work together? Are we taking the long view? Are we incorporating climate change and looking at specific vulnerabilities and opportunities that might come from those changes? And in doing so, really making more robust any investments that we make, and more meaningful, really, any investments we make at the sort of end user, if you will, or on-farm irrigation efficiency side. So next slide, please. So I copied Janine's last slide here just for a little bit of context. So again, this is California, more or less here on this slide. And what I've done is circled roughly the Merced River Basin watershed. This is an area that I'm going to be focusing my discussion on today, and it's an area where we are pursuing what we're calling a watershed scale study, or a climate vulnerability and adaptation watershed scale study. And so this is again the Merced River watershed. It includes about 140,000 acres of farmland, which from my calculation is about 57,000 hectares. It's an incredibly important agricultural center, both economically and otherwise. The watershed extends from the top of the Sierra Nevada watershed, or the Sierra Nevada mountains rather, at about 3,000 meters tall, all the way down to the floor of the Great Central Valley that Janine pointed out earlier. And it's an area, just like so many others in that neck of the woods, that is really challenged in a lot of different ways. We've heard a little bit about drought so far, how drought can lead to groundwater overdraft. Janine mentioned some of the potential, and actually not just potential, but the real impacts of groundwater overdraft, land subsidence, permanent land subsidence, irreversible land subsidence being one of those. It's an area that suffers from depleted surface waters, both linked to drought, but also climate, which we'll talk about in a minute here, with the associated environmental challenges that come with depleted surface waters for fish and other wildlife resources. And it's also an area that suffers from intense flood risk. And so it's an area that's very flat down there at the base of the mountains. And so traditional flood risk reduction infrastructure has more limited value in this region than in some other areas. So always needing more creative solutions to flood risk as well. Next slide, please. And that's what I just laid out very, very briefly and very incompletely are some of the risks, just some of the risks and some of the challenges that that region sees today. But when we think about under a climate change scenario, pretty much each of those, if left unaddressed, will almost certainly become worse. And so when we look at how can we learn more about and invest as smart as possible in a watershed like the Merced Basin watershed, we have to get a really good handle on what climate change is actually going to do there. We can't just look at the current challenges, we have to look ahead and say, what is the most likely outcome of climate change, and invest in solutions that adapt appropriately. Turns out here we are applying in the Merced River watershed, Merced River Basin area, we are applying UNESCO endorsed, really UNESCO-led effort called CREDA, or Climate Risk Informed Decision Analysis, which is really a beautiful thing. It says we can now, with analytics, not just give ourselves the range of potential future scenarios under climate change, essentially doing what we've done in the past, but just treating them all equally and saying, well, here's the range. The future scenario is somewhere in there. We can actually apply this, what's called bottom-up decision scaling analysis, and say, you know what, each of those future climate scenarios for a given location, in this case, again, in the Merced watershed, has a different probability of actually occurring. So when we look at the most probable climate outcomes and the most probable climate outcomes for individual pieces of water management infrastructure, we can start getting a much better idea of both the vulnerabilities, but also ultimately the adaptation strategies necessary to address those impacts. So what we see here on this slide, I'll walk through it pretty quickly, and you can check out the details if you want to zoom in later. If these materials will be available. If they're not, we can certainly make them available. But the bottom line is on the left-hand side here, what we're seeing is that in all likelihood, climate change will drive reduced inflows to the watershed's main reservoir, Lake McClure, during the dry months. And in the wetter months, in the winter months on the right-hand side, we will actually be seeing more inflows. So were we to look at these in combination just across a single year, a lot of this information would be, if not all of it, would be completely lost. But being able to separate it out by season, and then being able to again zoom in on what the relative likelihood of climate scenarios is going to be on specific pieces of infrastructure, we can get information like this. And what this is of course saying is that drought's going to be more challenging to manage. Less surface water available in general for the agricultural sector and even the municipal sector, but we're talking about agricultural sector today. But does the fact that that's mirrored in the winter months by more inflow provide an opportunity for us to better manage our system, to more efficiently manage our watershed, getting back to this larger theme of watershed scale water use efficiency? And in fact it does. And so what we're going to be talking about on subsequent slides is, for this one particular piece of the puzzle in this watershed, how can we manage and deal with the fact that we're going to have more water in some months and less water in others? Might it make sense to move beyond the talk about conjunctive management, which has been happening for a long time, and in some cases having been applied, and really move towards how do we turn the dials on our surface water reservoirs with groundwater replenishment in mind? How do we move water when it's wet into areas where we can replenish our groundwater basins, and in doing so be able to rely more on those groundwater basins during periods of surface water deficit? So next slide, please. What we need to be able to do, and basically to be able to do that, is have a much better handle on all of the water in the system, from the top of the watershed down to the bottom, where it's moving, when it's moving, what the operations of our reservoirs are, and then also, which I'll get into next, we need to have a very good sense for what the lands are, where they are, that can actually receive water for groundwater infiltration during those wetter months, again, to bank that water for the subsequent drier months. especially under that climate change scenario. Next slide. So what we'll be walking through here, each one of these polygons simply represents a model or multiple models that our team is stitching together to again create this bigger picture, watershed scale of where is all the water, what's it going to be doing in our climate change scenario, what are all the operations of our facilities, next slide please, and where's the best place to put groundwater, because not all areas are created equal for groundwater replenishment. So rainfall runoff, snowpack, reservoir operations, next slide. There's also a number of creeks in this watershed. It's not just about the Merced River and the larger Lake McClure Reservoir. Next slide, please. There's also the groundwater basins. We're learning a lot more about those, and we'll hear about those in the next panel discussion, I believe. So stitching all these together. Next slide. So now again, where's the best place to put the water? Where can it actually percolate through? What are the current land uses? Next slide, Josh. So where are the existing irrigation districts, the local public agencies that already have infrastructure to move water around, at least locally, from point A to point B? Very important to get a handle on our ability to move water from one place to another. Soil suitability. What's the best type of soil in the ground now for percolation, for application of water? Next is depth to groundwater. We always need to have a good idea of where are the cones of depression, how far down is groundwater, where is the depletion most severe, and does that provide opportunities for replenishment? Corcoran clay, simply a name of a challenging layer to replenish beneath. So again, subsurface strata, what's going on? What's the geology underneath the soil? Subsurface permeability, it's just that same kind of an idea, but again, another layer, another model, as we learn more and more about what's going on underneath the surface. Land use. All those previous layers are really important, but we can't forget about what's actually happening in the real world today. So here you can see, if you can see that small, where the different crops are, where are the urbanized areas. Groundwater replenishment works for some crops, it turns out. Some annuals, of course, make most sense in some areas, but also some tree crops can also tolerate groundwater replenishment. And when you take all of that together, is what are the most exciting, most potential emerging recharge sites? So where we can actually move water again during the wetter months to replenish groundwater basins for use in the future. Don't worry about the details here. The tall bars simply say these are wet years in these various sub-watersheds within the Merced River Basin. Those numbers are on the left-hand axis in acre feet, so you can see that trend of wet years, very dry years, wet years, very dry years, flood, drought, flood, drought. The purple line, whose metric is on the right-hand side, is simply a running total of acre feet or a volume of water that we believe through a pretty modest system of conjunctive use in this watershed, we can essentially bank in the groundwater system, raising groundwater levels, offsetting what would otherwise be surface water use during critical environmental seasons, and essentially squeezing more efficient water out of the system. Next slide. This is my last slide. Just a couple of observations so far in this really exciting work, and I've really only scratched the surface of it. Understanding localized climate vulnerabilities, whole system analytics, how all the different pieces can mesh together, and of course, bringing in a healthy dose of creativity are key to making real gains here. So just some really important pieces that seem to be coming together. Also, more efficient operation of our existing systems can uncover significant supply opportunities. So to some, 47,000 acre feet of water per year doesn't sound like a whole lot, but it turns out that you can do a lot with that amount of water, essentially making the system that much more efficient, that much more productive, that much more resilient to the impacts of drought. And then lastly, watershed scale efficiency complements on-farm efficiency. This is really what I wanted to start out by saying, and that is that they're both important. And arguably, I would say that investments in one and not the other reduce the overall impact of what you are investing in. And really, we need to be looking at both. And that's why it's so wonderful working with our sister agencies like California Department of Food and Agriculture and others, and partners like you across the world to get better at both, because they're both certainly necessary. So I will end there and look forward to the discussion. Thank you.
Chris, thank you so much. I greatly appreciate it, and a great presentation. Definitely we see the challenges going forward as we try to implement the Sustainable Groundwater Management Act, especially on the agricultural regions within the Central Valley, and definitely recharge, flood mar, and a lot of those strategies in terms of water use efficiency are critical. And so now it's my pleasure to introduce my dear friend, Carla Nemeth, who is the director of the California Department of Water Resources. Carla and I had a great opportunity to travel to the Western Cape and see their great agricultural infrastructure last year. So again, Carla, thank you so much. And I'd like to turn the presentation over to you.
You bet. Hello, everyone. Good afternoon. It's a pleasure to be here, and thank you, Josh. Josh and I were part of a team that had a terrific trip a little over a year ago to the Western Cape, and I certainly learned a lot, and I am just continuously struck by the similarities in our systems and our challenges. So it's great to be able to share a little bit with you all today, and I look forward to learning a little bit more about what you're doing, what more you're doing in the Western Cape. What I want to talk about is sustainable groundwater management. So I think Janine did a terrific job kind of setting up the dynamics in our state and sort of this layered history of water. And then Chris is really focusing on what I would consider as really the next frontier in our solution sets. And then I'm going to talk about a new regulatory framework that is really also driving us to make better use of these kinds of solution sets. And it's really, it's great to get all this larger scale analysis underway, but of course, as you all are probably familiar, you know, unless folks at the local level see it as solving a problem, it's harder to get traction on that. So Chris's presentation is a good segue into my presentation, which is, you know, what's the new problem we're trying to solve here in California. So next slide, please, Josh. As you know, I'll just go through a few of these setup slides. Agriculture is the largest water user, and it's the largest water user here in California. We're very, very proud of our agricultural history and our innovation. And here in California, a lot of our ag users are among the most efficient in the world. And so while there's necessary improvements to on-farm efficiencies, particularly those operations that have kind of been on the bubble because of the lack of reliability of their water supplies, they have become extremely efficient here in California. Next slide, please. As I mentioned, we are the 5th largest economy in the world, so we've got a lot at stake in terms of how we manage our water resources. Next. And one of the most amazing things, at least to me, is California is often considered, you know, the vanguard on so many policy issues in the United States. But in fact, we were the last state to manage our groundwater resources. And that is in large part due to our history with water in California and the fact that it is managed at the local level, and you're going to get a sort of deeper flavor of the complications that that creates. But what it also means, sort of being the last, is it means we have a lot of problems that were that developed over decades, really the last 100+ years, that we now have to fix. And we also have to fix them with an eye towards the future, because climate and more extreme weather patterns are going to really disrupt what we know. So we really can't rely as heavily as we normally would on hydrology, past hydrology, and everyone needs to stay focused on where we have consensus around extreme weather patterns that climate change is generating. California's groundwater supplies are hugely important to the state. I think as Janine mentioned, in an average year, nearly 40% of our water supplies come from the ground. And then in dry years, you can see that that shoots up to about 60%. And that's actually the rhythm that we want to maintain. But the challenge is what we need to do is make sure that during the dry years, we have water in those groundwater basins that's clean and plentiful to help us survive these droughts. Next slide, please. So it can't be stated, it can't be overstated that California's agriculture is heavily dependent on groundwater supplies. 77,000 farms depend on it, and those farms generate about $50 billion in revenue. Next slide, please. Those groundwater supplies also support an incredible amount of biodiversity in California. We are one of the world's biodiversity hotspots. Similar to South Africa, we also have a population that really values our environmental diversity. So we have a large contingent, if you will, of advocates who want to make sure that our groundwater systems also continue to support the ecosystems in California. That includes microorganisms, fungi, plants, and animals. Go ahead, next slide, please. So for the last 100 years, surface water in California has been actively managed primarily at the local level, not at the state or federal level. And now we have just launched ourselves into our new reality of managing all waters below the ground. That was legislation that passed in 2014. So we were headed into a really deep drought. We were in about year 3 of 6. And so we started to implement the law in January of 2015. Next slide, please. As you all have an awareness, our groundwater systems are vulnerable, particularly if left unmanaged and faced with the changing climate. The notion that we need to identify and build the infrastructure when we have these very wet periods that can enable us to recharge our groundwater basins is only becoming more and more important in California. Next slide, please. So the question we ask ourselves and are redefining every day is, what is sustainability? So in the broadest conceptual sense, sustainability means managing our water resources to meet the needs of today. That means water for drinking, farming, and the environment, and doing so in a way that's not going to impact the ability of future generations to meet their needs for a sustainable supply. Next slide, please. I think the big challenge here, though, is while we're looking at meeting the needs for today, we do have some enduring degradation of existing water supplies. So here in California, not only do we need to sort out what a sustainable future looks like, we need to bring a lot of our groundwater basins, particularly those in our primary agricultural area, that area of the Central Valley, we need to actually bring them up to sustainability for our current needs. So we define sustainability as avoiding 6 undesirable results. And these are all definitions that are included in our groundwater management law. So we need to avoid lowering groundwater levels, avoid the reduction of storage, where, essentially in certain groundwater basins, if you remove too much water, you're actually reducing the capacity of the aquifer overall. So we want to avoid situations that reduce the volume of groundwater storage. We need to avoid seawater intrusion for those groundwater basins along our coast, degraded water quality, land subsidence. We have some real challenges in our Central Valley in California with land subsidence and its impact on infrastructure, in particular, impact on the big canal systems that Janine described that actually deliver surface waters to those very same communities, and surface water depletion. So that's where overpumping of a groundwater basin starts to deplete water in our rivers and streams because it's permeating the riverbed to recharge those depleted groundwater supplies and creating a disruption to our ecosystems. Next slide, please. So the Sustainable Groundwater Management Act, meaning all these groundwater basins that now need to comply and become sustainable. We have 515 groundwater basins identified and mapped in California. 94 of them are subject to this new requirement. And that essentially means by various metrics, the 515 groundwater basins have been analyzed, and about 94 of them are in a situation where they, if left unchanged, we would start to see those undesirable effects emerge if they're not there already. And then 21 of those 94 are what we classify as critically overdrafted basins. And you can see from this slide that the vast majority of those critically overdrafted basins are really in the heart of California's agricultural sector here. Go ahead, next slide, please. Groundwater governance is going to be a huge theme, and I want to point out that we have a lot of state and federal partners that help us with this, but I think more importantly and even more challenging is the passage of California's groundwater management law has generated more than 280 new groundwater sustainability agencies. So if there's one big takeaway from water management in California is that it is done at the local level. And it's been done at the local level for a very long time through our water rights system. And so there is nothing that we do at the Department of Water Resources that doesn't involve intense partnership with local water agencies. And we now have north of 250 new ones that we need to continue to work with. Next slide, please. So our particular role as a department in administering this law is we have a regulatory role. That is generally new for the Department of Water Resources. Most regulatory responsibilities in the water sphere happen at what's called our State Water Resources Control Board. And they do two things. One, they administer our water rights system, but they also have delegated authorities by the federal government for clean water and water pollution. So DWR has traditionally played the role of planner, grant maker, an entity that really incentivizes all these local agencies I've been mentioning to plan better for local resilience. So our administration of the Sustainable Groundwater Management Act puts us in a new regulatory role where we review all the plans coming in and we assess whether or not they meet the requirements of the law. If they don't, they essentially go to our Water Resources Control Board, where through our water rights system, that board can impose water use regulations on all these individual landowners in the Central Valley. So part of the approach here is to essentially launch the department into a new regulatory role based on our partnerships with these local agencies, based on our history of partnerships with local agencies to help them comply with the law. But we know that in the state, we do have a backstop, which is this Water Resources Control Board. And if local entities can't come together and establish a plan that meets the law, then they will be subject to a lot more specific and frankly a little bit more draconian kind of command and control water use regulation. The department also plays a role in providing assistance. So we have an assistance branch where we provide new modeling information. For example, we've been partnering with NASA, our National Space Administration, to do satellite imaging, particularly for things like subsidence throughout California. So that's just a real example where the department can partner with other entities to provide good information that all these new groundwater agencies can manage. We have a new thrust in California, water management, which is the transparency of the data that we collect. That's going to be a significant feature in successful implementation of groundwater management. So all of this information that DWR is generating, that these local agencies are generating, they're available on a portal to the public. It's fairly technical, and part of our challenge over time is how to make this kind of technical information, more and more available and accessible to the lay public. Also within our regulatory role, so I think I have it on a future slide, but our groundwater management law is set up where groundwater management agencies need to demonstrate that by 2040, they are managing their groundwater basins to the successful avoidance of all the undesirable effects that I mentioned. So part of our challenge is we are working on regulation and working on plans that essentially need to fix problems that have been generated over the last 100+ years within a 20-year time frame. And we are right now starting to review some of those plans, and I would just observe there's a lot of anxiety about passing or failing, but the reality is plans will be submitted. Our department will render its judgment about whether or not it's adequate under the law. But then every 5 years, these plans need to report back in to the department where we reevaluate whether or not they're meeting their plan's objectives and whether or not their plan itself is still adequate under the law. So a very quick crash course in history. As you can see, it's not as though California were doing no groundwater management. It's just that up until this point, it was all voluntary. Next click, please. And then you can see going forward, since our Sustainable Groundwater Management Act passed, we have a set prescription for required groundwater management. Generally, what this means is we have a wide variety of entities, local water districts, local counties that have varying degrees of experience with groundwater management, technically speaking, an incredible variability on available data, even information about local geology is variable, information on number of wells, on water quality in those groundwater basins. So I think one of the big challenges for the department, but also the big opportunity for California, is to provide some consistency in that kind of information, and also start requiring these local agencies to track things a lot more closely than they ever had before. But it does generate a situation in California where, across the board, there's frankly, a real lack of equity in how groundwater management supplies, our groundwater supplies are managed, and the skill sets that these local entities have to manage those supplies. Next slide, please. So that concludes the presentation on groundwater management. I want to end by connecting it to some more of Chris's presentation, and I think a slide that was in Janine's presentation. So if you remember, Janine had a slide where you could see periods of flood and you can see periods of drought. And what we're trying to do with our groundwater basin is move water during periods of flood and use it effectively to mitigate aspects of prolonged drought. And one of those most important aspects is putting that water underground in our groundwater basins. And the information that Chris presented is it's fascinating, and it's pretty cutting edge stuff for us here in California, in that we're starting to look at watershed scale integrated planning efforts and the way in which we can bring new information to the table about water available for replenishment in these groundwater basins. That is going to be key to our success in sustainably managing groundwater supplies, but doing so particularly in the Central Valley that can minimize the impact on California agriculture. So that's going to require an enormous amount of coordination at the local level. And it really is, in my mind, as the director of DWR, one of the most significant challenges that we face into the future. One of the things that's really clear about groundwater management in California, and in my judgment, I don't think we would have had a chance with our previous governor, Jerry Brown, to even pass a Sustainable Groundwater Management Act if we didn't fundamentally vest responsibilities at the local level. So all that information is coming back from these new local agencies. But what's missing right now is the coordination among those local agencies. Because as Chris's presentation demonstrated, you know, it really is the watershed scale. So we've developed a lot more jurisdictions within that watershed scale, and those jurisdictions now have to coordinate when it comes to the solution sets to enable their groundwater basins to recover and be managed sustainably into the future. So that is a key challenge for California, where we haven't, I don't think we've established what, you know, what the success is or what the program looks like to incentivize that kind of regional collaboration amongst groundwater management agencies. But that's, you know, that's the cusp of what we're working on today in California with a lot of our climate resilience work that we're doing under our new governor, Gavin Newsom. So thank you for the opportunity to present that perspective here, and I will appreciate the discussion going forward. Thanks, Josh. I'm going to turn it back over to you.
Thank you, Carla, so much. I greatly appreciate the presentation. And personally, thank you again so much for your leadership on this issue and your engagement, not only cross-agency, but also engagement with stakeholders in the agricultural and other sectors as we move forward on this adventure in regards to SIGMA implementation. So thank you so much. And now I'd like to turn the discussion over to Dirk for introductions of our next speaker. Dirk? All right, Marlene, if you are available, I'd like to turn the presentation over to you. Marlene is the Director of Biodiversity and Coastal Management in the Western Cape Department of Environmental Affairs and Development Planning. She is passionate about enabling people-led sustainable development. So Marlene, the floor is yours.
Thank you, Josh. And just interesting, picking up from the previous speaker, isn't it interesting that some of the key challenges relate to our social and institutional capacity and our ability to coordinate all of that in bringing to bear a sustainable management of our resources. So I'm going to focus on a similar theme. It's around ecological infrastructure and a project that we are currently working on transversely within the province, speaking to specifically a risk-based approach to trying to coordinate investment into ecological infrastructure. Next slide, please. Josh, I'm going to have to warn you, we'll be moving quite quickly. So for those of you who don't necessarily understand, the term ecological infrastructure is effectively a network of interlocking and related and interconnected structural elements in the landscape. It's effectively the same as the built infrastructure, except it's a nature-based infrastructure. So how we look at the environment, bringing together the economy, society, and the natural environment. Next click, please. Is effectively the environment and ecological infrastructure. Next click. Encapsulating the built infrastructure. So the key message that was always pushed through during our drought and is still a resounding theme is water doesn't come from the tap. It doesn't come even from dams, pipes, and weirs. In fact, water comes from the natural systems and primarily the mean annual runoff that provides for that, all of which is subject to significant changes in our immediate and medium-term future in terms of climate change. Next slide, please. So we have many threats to ecological infrastructure in the Western Cape. Unsustainable use. We're seeing a large-scale transition towards groundwater abstraction as well. And that is also a huge concern in terms of the effects on surface systems, but also on natural systems. Transformation and changes in priority areas of watersheds, some unlawful practices, urban development and infrastructure in certain sensitive areas, general land degradation, threats from fires, critical issue, lack of coordination in management and investment in the landscape, and then something I'd like to focus on, invasive alien species and their spread throughout our watersheds. Next slide, please. Okay, so our challenge is manifold, but critically, we are a water scarce region. Our rain comes in the winter. Our dry season is when we all need the water. We have critical surety of supply area issues in relation to some of our coastal towns, but significantly our climate change projections into the future speak to a 30% reduction of annual rainfall by 2050, and heralding in an increase in frequency and intensity of droughts. We've already experienced that very recently. So water economy and water will increasingly be the limitation on our economy. So we can simply not deal with a business as usual future. There are many options to augment current supplies. Some of them I've mentioned, but the most effective option, and the one which can certainly provide for the improvement of the source of our water, is the eradication and the proper management of invasive alien plants within our critical catchments. Additionally, this is a huge ability with great job elasticity, and in terms of a response to climate change, it provides a no-regret ecosystem-based climate change adaptation strategy, and furthermore provides for further system resilience moving forward. Just as an aside, some of you may have seen Swiss Re launched their index, Biodiversity and Ecosystem Services Index, last week, I believe. And some of the information heralding in that new system and that new index speaks to 55% of our global GDP being dependent on these ecosystem services. And the concern, and we should really think about and listen to our reinsurance and insurance sector. They understand risk possibly better in terms of the economy than many of us, that they are raising some enormous red flags in terms of the deteriorating and the vulnerability of our natural systems on which our GDP does depend. Next slide, please. Okay, continuing on the challenge. These are two maps of the Western Cape. The subdivisions there you can see are quaternary catchments. What we're looking at is effectively the shift and change in terms of mean annual runoff reduction over a period of 25 years. And that is basically showing that if we don't really get involved and actively coordinate our efforts around ecological infrastructure and specifically invasive alien plants, we are looking at a significant mean annual reduction from that as well as climate change. Please, next slide. Okay, so what does this all amount to? Our invasive alien plants effectively change our river systems. They shift things into a different mode, can cause flooding in some areas, massive wildfires impacting our urban interface, but also other agricultural infrastructure. These are the issues which we are also dealing with in terms of flooding, coastal flooding, and risk. Next slide, next click, please. So ultimately, this results in the significant cost of disasters in our province, and that I believe my colleague, Mr. Denyer, will speak further to that later. Next slide, please. So what is the purpose of the EIF? Ecological Infrastructure Investment Framework is to guide decision makers in the public and private sector. So really a transversal and a partnership approach is to how and where to invest in order to improve the resilience of these resource-giving natural infrastructures. And our specific focus here on 4 dimensions and vulnerabilities and risks: water supply, both surface and groundwater, risks of wildfires, risks of flooding, and risks of erosion or rangeland degradation. Next slide, please. Okay, just to encapsulate a little bit further, if we're looking at invasive alien plants and the combination thereof, climate change and inappropriate land management, these are effectively the pressures and the impacts which we need to work to try and deal with the associated investment to enable the ecosystem goods and services to be resilient into the future. Next slide, please. Just zooming out to our national context, strategic water source areas of South Africa, which is only 10% of our surface area, provides for 55% of our mean annual runoff. It supports at least 55% of the population's needs. Jumping down to us in Cape Town and in the Western Cape, we are 98% dependent for our water supply on these areas. I think our next slide zooms into the Western Cape to provide a similar view. Next slide, please. So we're looking at our water source areas in the Western Cape, and here you can, they're just highlighted in terms of mean annual runoff, but to focus on the 98% of our city water supply dependent on these areas directly. Next slide, please. So for some, this looks like a beautiful picture, but what you have in the background, in the foreground are some less dense and invasive aliens. Those are actually pine trees. And in the background, in the snow-capped mountain, very dense infestation of alien pine trees. These are inaccessible catchments, mostly, which are going to take some investment and coordination and effort in terms of clearing them. But they are a priority in terms of what we've identified in our ecological infrastructure investment framework. Next slide, please. So invasive alien species, just to show these ringed areas here are effectively our strategic water source areas and sort of underlain by our canopy cover of invasive alien species. So just as a brief background to this, a lot of our invasive alien species in the upper catchments are effectively areas which are infested by escapee plantation species, mostly pines and eucalypts, but not only. There are other species such as hakea and the cocktail of acacias that also impact our riverine systems. Next slide, please. And then this is just another illustration of the mean annual runoff reduction due to alien invasive plants, also mapped at the quaternary catchment scale for the province. Next slide, please. And this is going into the description of our project. So we have effectively done a staged-wise approach to this, firstly looking at catchment prioritization, very much driven through stakeholder approach in looking at prioritization criteria across the province, focused on those different dimensions, as I've mentioned: water security, fire risk, flooding risk, and land degradation. Next slide, please. These next few slides are the result of our catchment prioritization based on the criteria we've developed with stakeholders. So this is the view for water security. We've kept them separate and disaggregated, but we can aggregate them. The issue here is that we need to use this model to be able to serve different interests. So if it's for water security you want to invest, well, let's use this prioritization layer. If it's around wildfires, we would use a different prioritization layer. Please proceed to the next slide. Our wildfire hazard also mapped at the quaternary catchment level. Next slide, please. Rangeland degradation. And then finally, next slide, please. Flooding. flood degradation and risks thereof. Moving on to the next slide, this takes us back into the next stage of the project work, management unit control plan. So based on that spatial prioritization, we've identified also a drill down to a specific priority watersheds in order that we can start to do detailed planning with stakeholders. We've selected 2 for this stage of the project, and the next couple of slides just illustrate what a management unit control tool can do. It's effectively modeling different investment, different effort and costs, as well as work generation, and then flowing from that, what water can be released through that process. Next slide, please. And you can skip through the next maps, Josh. So maybe just to say that this incorporates the data sets, bringing in the mapped prioritization. It's effectively a system for calculating resource requirements. Next slide, please. Just an illustration. Thank you. It also provides for you then, based on your scale and rate of investment, how quickly you can actually get through the job. Next slide, please. Okay, and we have also developed an integrated investment framework, and if you can skip to the next slide. Vision for this is that by 2040, the people of the Western Cape live and organize themselves in a way that promotes healthy and resilient ecological infrastructure, so that it yields the goods and services that support physical, psychological, and spiritual well-being in the face of population pressure, rapid urbanization, and climate change. And then we've got 4 key priority objectives: effectively the water quality and quantity, the reduced vulnerability in terms of the threat of uncontrolled fires, improved land management practices, and then also to reduce the exposure to the impact of increased flooding. These are the critical objectives that have underpinned the study and the risk modeling. Okay, we're at the stage now where we're developing an implementation and monitoring plan. It happens to come at the same time as our COVID economic recovery plan. We are trying to find every opportunity to attract the investment, specifically in terms of creating work opportunities, but building back better in the context of our economic recovery, that this is a no-brainer opportunity for investment to create jobs, to improve our resilience generally in the Western Cape, and expressly in the context of this workshop, to improve our water security in terms of our catchment management, our watershed management. Next slide, please. Okay, so the opportunities that exist, I'm not going to run through them, but conservation agriculture, we've worked in partnership with our colleagues in Department of Agriculture specifically on that. Our agricultural colleagues have actually, I think, led the charge in the country in terms of conservation agriculture and approaches to looking at climate change resilience into the future. Integrated fire management, we work together with our colleagues in disaster management to look at that. And then I want to focus specifically here on biomass export and value added industry. So there's a lot that we can do with the biomass that is cleared from these areas, more than just work opportunities, but specifically in the transition of some of our European country partners who are moving out of coal-fired generation into other forms. Pelletized biomass is one, but also some very innovative projects which are going to expand these value chains. Next slide, please. Just looking at an example, a drill down into one of our partners, the Nature Conservancy, which is looking at a water fund for some of the city catchments, City of Cape Town catchments, and this looks at annual costs, water yield, benefits, and jobs created, and it shows you that at a point your costs do come down and your benefits in terms of water yield continue to improve while your costs stay stable in the maintenance phase. Unit reference value costs in terms of the different options of supply. Here we go, catchment restoration, by far the most best return of investment, because our opportunities to build new dams has pretty much disappeared. Next slide, please. Except for maybe the increased height of some of our dam walls, which is being considered. Then just speaking to the interventions moving forward, critical in trying to ensure collaboration and cooperation and bringing together the institutions and partners in this process is good information and good monitoring systems. It's a huge challenge, specifically in terms of being able to direct where that investment should occur, but also getting a better understanding of the harvestable biomass for export and improved decision making around water security and allocations. Next slide, please. The clearing here of invasive alien plants, just sort of drilling into the opportunities in terms of the additional yields per ton of invasive alien plants cleared, and there are general amounts, but they're good indicative amounts, and then also the ability of that investment to leverage work opportunities, which we're actually desperate for in our post-COVID recovery space, and obviously unlocking at the same time value-added industries in biomass. Next slide, please. Just to highlight some of the value-added industry opportunities, taking biomass and converting that into jet fuel and other kinds of fuel, and also then looking at composite products for not just planking and building materials, but biochar for water treatment in charcoal filters, mulch in terms of increasing our ability to conserve water in conservation agriculture, and then also as feed. And then moving into my final slide, my final two slides, I think. Just an illustration here. This is in one of the priority catchments. What you're seeing there is a very large ungulate, and that is a huge stockpile of cleared invasives. And then to the final slide, just to get the spatial perspective in terms of scale, there's that same ungulate next to a massive stockpile of the biomass that can be processed. Thank you very much, colleagues. My final slide is just to say thank you.
Perfect. Thank you so much, Marlene. We greatly appreciate that. I'd like to now turn the presentation over to my colleague, Dr. Amrit Gunasekara, who leads our Office of Environmental Farming and Innovation here at the department and is the science advisor to our secretary. Ami?
Hey, thanks, Josh. Quick sound check, please. Can you hear me okay?
Yes.
Great. Good morning to those in California and good evening to those in South Africa. Pleasure to be here. I'll quickly go over a presentation on how we are working to improve on-farm water efficiency in California. A quick overview of the program that I run. This is the Office of Environmental Farming and Innovation. We run several incentive programs, have some demonstration projects. We are very much interested in information sharing and webinars and developing a climate smart adaptation database that's open source to the world, and also do a little bit of research. Next slide, please, Josh. These are the incentive programs we run. One more click, please, Josh. And we're going to talk about the State Water Efficiency and Enhancement Program in this presentation. Next slide, please. So SWEEP provides financial assistance in terms of dollars to farmers and ranchers who want to implement irrigation systems that save water and at the same time reduce greenhouse gases. This component here on greenhouse gases might seem rather strange, but the reason we have it in there is the funding source is from the California Cap and Trade program, which works to reduce greenhouse gases in the States, it's actually the revenue that comes from selling the revenue that comes in from the permits that are generated. And so the state agencies apply for these funds and then try to reduce further greenhouse gases in their sectors, and in this case, the ag sector. So we received a lot of money since 2014 when this program was first started in CDFA. It began as emergency funding to address the drought. And you heard a lot about the drought. This is a historic drought in California with its peak in around 2014. We have funded about 820 projects, many acres covered. If you wanted, sorry about the acres, I know the folks in South Africa might like to go with hectares. So 1 acre is a 0.4 hectares. So you can do the math. We have about 9.5 million irrigated acres here. So we can't cover all of them certainly, but this is to really get the message out on how water efficiency can be improved on farms. We also have a match. These matching funds are important because these are what the farmers put in on their own money and time into these projects. And then we monitor the greenhouse gas reductions and water savings as well. One thing I should point out that the projects are verified at the end of the year and a half that it takes to put them in. And then there's a 3-year reporting metric that every year they have to send in their water savings and greenhouse gas reductions as part of reporting back to the government. One thing I will say is we don't do this for all the projects, we do it for a subset of the projects. And I'll talk about that in some following slides. Next slide, please. Okay, so these are the types of things that the program funds. The top image is a sand filter, a weather station to get more accurate ET, evapotranspiration. Next, click a couple more times, Josh. This is drip irrigation, micro sprinklers. We fund meters for pumps for farmers that don't have meters on their pumps, and then also variable frequency drives. That means connecting the load requirements of the irrigation system with the pump, so you're effectively using the energy. We also fund some solar that helps with energy efficiency as well. Next slide, please. Okay, so in 2018 and 19, here's some of the things we funded by project and percentage. The top 3 are, of course, reduced pumping, which helps with the greenhouse gas requirement. And then we have irrigation water management. That's just making sure that you have better ways to turn on your irrigation and have better information to turn on your irrigation when the ET is at its highest. And then improved energy efficiency, as I mentioned, is the 3rd highest category, and that also includes solar. Next slide, please. Okay, so quickly about the drought. You heard about the drought from the DWR experts, but here's an image on the top on January 18, 2014. And the bottom image is actually from the previous year. And what you can see is the white stuff. That's a snowpack that then melts and provides the valley with the water it needs throughout the year and throughout the summer, really during the growing season. So you can see how much less snowpack we got at the same time between 2 different years. This is the drought monitor showing you how the situation was really bad, peaking in 2014 and 15. One more click, Josh. Here's one of our reservoirs that went pretty dry. I showed this image once and someone thought it was actually a river and had no idea it was actually a reservoir that had gone dry. Next slide, please. So in this state, What we are most known for is specialty crops. That's all the good stuff you use in your fruit salads and your vegetable salads. We are known for these specialty crops, these high value crops. The best way to think about specialty crops is to it's those crops that are not grown in the middle of the country. For example, it's not corn, soybean, and wheat. It's all those specialty high value crops that are so nutritious and we all love. Next slide, please. So that California leads the nation in these specialty crops. We grow lettuce in the winter here in the south, which is essentially a desert that is then shipped around the country while the rest of the country is under snow. So in 2018, you can see the grants that we funded. Here are some examples of the distribution. So on the left-hand side is those folks who applied with the different types of production systems. We have vineyards, row crop, annual fruits and veg, forest, a mix, and then orchards. Our orchard crops, for example, our almond crops are now over 1 million acres, and you can see the large percentage of these grants going to that, which is representative of our agriculture systems here. It's not that we absolutely don't grow corn. We still grow some corn and row crops because we use them for forage, for animal forage. What we don't see a lot of coming into the program is these crops, because a lot of them are still flood irrigation. And really what we're promoting here is micro sprinkler and drip and subsurface drip, which then provides greater efficiencies on watering. We know there are plans to try to bring these irrigation systems into row crops, but some experimental work needs to continue to be done to get that there. So what are the water sources being used? So the drought really exacerbated the use of groundwater, because what happened in 2014 was that there was zero allocations of surface water to growers. So a lot more growers went to the groundwater. And now the sort of infrastructure needs to catch up with the on-farm, on-demand needs, because before it was really flood and furrow irrigation, and you had a schedule where you got water on certain days. Now with efficient irrigation systems, you sort of need an on-demand source. And so once you put in a pump, it's sort of hard to go back from a pump to surface water. So this is something we see represented in our applications, and certainly hope the irrigation systems also work to provide benefits on a more on-demand basis. Next slide, please, Josh. Okay, quickly. I told you for 3 years, growers who get these grants have to report back to us. So here's a subset of 13 projects where we required this data, and this is on the greenhouse gas reduction. So the baseline means this is their baseline before they applied to the program, what they were using, and then after they actually when they apply, they say, hey, in 3 years we're going to estimate our reductions. And so what they estimated is in the second bar in the middle. And then for the 3 years they implement the project, and then they also have to report over those 3 years. And for those 3 years we collect that information. And then you can see here the third bar is actually the observed for the 3 years, which is actually better than the estimate, which is really good news that this program is working to reduce greenhouse gases. Next slide, please, Josh. The same can be said on the water use piece. You have a baseline that they were using, and then they applied to the project with an estimate, which is the middle bar, and then they monitored their use. And you can see that the observed 3 years is actually better than the estimate. And for the estimate, they have to use a water efficiency calculator and also a greenhouse gas calculator as well. Next slide, please. Okay, So one thing I want to say is there was a question on how this helps with Sigma. So what we are really advocating for is conjunctive use, to put in an efficient irrigation system during your growing season and use the growing season, and then in winter time use your surface water when you have peaks of high rainfall to then flood your fields, and then you have some infiltration going on. This is called FLOODMA, or Flood Managed Aquifer Recharge, and we're trying to align it with ag fields. I just want to quickly recognize our SWEEP team. We have some wonderful people who work on the tech team and also on the admin team, making sure all these invoices are paid and all the required documents are provided to us. So thank you, Josh.
Ami, thank you so much, and thank you and your team for all the great work that you're doing on the ground with our farmers and ranchers. Thanks again. At this time, I'd like to turn it over to my colleague Dirk with the Western Cape to introduce our last speaker. Dirk?
Thank you very much. Everybody know that a few years ago, the Western or Cape Town was the first big city in the world that actually approached day zero when there's no water in the pipes. Now, the person that managed this disaster from a governance perspective is Mr. Colin Diner, and he's the head of disaster management and fire rescue service in the Western Cape province. So he's responsible for the management of all the declared disasters, including the drought disaster, and he's more recently was also responsible for the COVID-19 disaster. Over to you, Colin.
Thank you very much, Dirk. Yeah, I was responsible, I suppose, for managing the disaster, not for the disaster itself, I hope. So what I'm going to speak about really is just the fact that I think, and as Dirk really very well mentioned it, not only to try and prevent day zero and avoid it from happening, and day zero was really at the point where we would have had to go into emergency water provision, and that was pretty much the definition as it worked out. But it was also about how do you manage a province where you've got 6 million people and you do not have a water supply. So those were the issues that we had to deal with. Next, please. Okay, so Aisha Peterson spoke a little bit earlier about the 3 years of disasters. So January 2015 was when we started seeing in the Central Karoo, to the north of our province, we started seeing a lot of strain on farmers in the increased cost of fodder for livestock. We put together a team of professionals. They went and did assessments, and then you'll see that only much later did we have our first meetings. Now, the reason for that is our winter rainfall season happened in between, and obviously we had an extremely dry season, which then around November we realized that we actually have to start looking at what was happening. So we did a much more in-depth provincial scan around that period, and 3 towns in that northern area were found to be in dire need and on the verge of running out of adequate water provision. So we took further assessments. We established a specialist team, and then we requested that 2 district municipalities be classified as agricultural disaster areas. At this stage, the Cape were flying pretty much solo. We didn't get any disaster grants or financial assistance from national government. Next, please. So our agricultural department supported with fodder relief. We then did in 2017 various assessments. We saw that the entire province was heading towards a very serious drought situation. And on the 25th of April 2017, the National Disaster Management Centre classified the province as a drought disaster area, and this was then later gazetted. In fact, there were 3 provinces at that stage that became classified as national disaster areas. Next slide, please. So that's just an idea of what the provincial drought task team that we put together, and a lot of my colleagues from the province that have also spoken today were part of that. We looked at what our weather outlook was. We were monitoring that, implementation of restrictions, determining the drought status, which were the high-risk areas, and then assisting with disaster declarations, communication with the national government, and funding allocations to drought relief. Next slide, please. Okay, then just to speak quickly about the declarations. Next, please. So just the top one is really what I want to speak about, and that is what we, in our law, what we classify as a disaster. So any occurrence which threatens to cause loss of life or widespread damage to property and cannot be effectively managed by the authority having jurisdiction, then it gets bumped up to the next level. And this is why a lot of the towns, and as well as the city of Cape Town, they were experiencing, this, and for the fact that it was such a widespread area, it was then classified as a provincial disaster. There's just the dates that the process went ahead and all the legalities that we had to follow. Next slide, please. So this is just, we developed this map, and you'll see it's quite an involved map, and obviously has many layers which we could put on and off as we needed to. And this is just a shot of a specific period during that time, where we looked at where were agricultural drought areas, where did we have hydrological drought areas, and then where did we have a combination of the two, which areas were declared as disasters areas and which were not declared. So we built on this system continuously, which gave us a very good picture of what we were facing and in which areas we were facing and where we had to carry out our most important interventions. Next slide, please. Yeah, so the provincial executive, the moment that something gets declared as a disaster, it basically becomes the responsibility of the provincial executive to manage that specific disaster. If it is a provincial disaster, obviously at a national level, like we've recently had with the COVID-19 response, it then is managed at national executive level. So it does give the Premier of the province fairly widespread powers to be able to do emergency procurement, release whatever resources are required, and issue directives and regulations. So it really does give you a lot of power to be able to deal with a disaster of this nature. Next, please. Okay, so the next slide, sorry, you can go to the next one. This is really where we needed to get practical. And how do we manage this? How do we look at this from a disaster management or emergency management perspective? So we basically broke it up into two parts. The one which you'll see on your left, which is provincial, that was really the province itself and the people in the province. And on the right-hand side, government, that is government business. So how do we keep those two continuing, and how do we support them in this area? So obviously, I've spoken quite a bit about the high-risk areas, which we identified, looked at what the mechanisms of intervention needed to be, looked at which areas needed special regulations for restrictions. And then what we did with groundwater management, because of the fact that a lot of our areas are reliant on groundwater, we appointed teams of geohydrologists, and we basically allocated them to each one of our regions. They went into those regions, they did assessments, they came back with a workable plan for each one of those districts to be able to operate. We fast-tracked environmental impact assessments, and then obviously support to agriculture. On the government side, we have two main functions as provincial government. The one is health, and we identified all our hospitals. We did exploration at all our hospitals, the drilling of boreholes, equipping the boreholes, and obviously being in a hospital situation, we needed to do water treatment as well to make sure that the water coming out of the boreholes was basically well suited for use. Education, obviously a lot more schools, a lot more of a challenge there. So again, what we did there was we determined more the status around water tanks, around how close were they to groundwater, and how could we solve the problem there. Also looked at engineering solutions for government buildings, how we could make them more effective. And then also every government department had to have a drought committee, which reported back to the provincial top management. Next slide, please. Next one. Okay, so this is just a bit of a background into the activation of the Disaster Management Center. What we do is we bring in all the role players. Everybody that has some sort of stake in managing this disaster, they get identified beforehand, and you'll see that we had the City of Cape Town, all our provincial departments, national departments within the province, and then all our parastatals, our electricity suppliers, telecommunication suppliers, organized labor. We had them all in, and they would work 3 times a week with us. Next slide, please. So this is what the structure looked like. So we developed work streams. You can see there a humanitarian stream, water security risk, economic security risk, and a safety and security risk, which was obviously the kind of security issues that you deal with when people get laid off from farms, etc. And you see a higher level of crime taking place. These teams would work together. They would develop their plans. They would carry their plans out, obviously on a very broad scale, a kind of all of society kind of approach. And you would then see the way that that flow would happen. It would go through to the various steering committees, our cabinet, our premier, as well as the executive leadership of the province. So that was really the way that this whole structure was put together. Next slide, please. So I'm not going to go much into this, but these were the strategic objectives, and I think I've just spoken to that just before. And really the strategic objectives, as I said earlier, was not only around preventing day zero from happening, but making sure that we are able to protect the province, the public of the province, their social well-being and their safety and security right through it. And from that is where our various work groups then actually came into being. Next slide, please. Okay, this is just my last one. We developed this drought dashboard. In fact, it's still working. It's still in place. It looks a lot better now. And what we were able to do is we updated it every week. We were basically on a weekly basis able to track every dam, the situation in those dams, the situation as it affects the specific town, the municipal area of that town, the agricultural area of that town, and that gave us a much more focused kind of response into how we needed to manage each of the areas, how we needed to resupply, for example, water into areas, how we needed to maybe reprioritize geohydrologists, etc. So this was very much a tool that guided us on our rapid kind of response that needed to happen. And I think that's my last slide. Thank you very much.
Thank you for this perspective on what happened during the drought and how it was managed. It is highly appreciated. Josh, I don't know, will we have time to take questions?
Definitely, we could take a couple of questions. If there was someone that would like to ask questions, if you could please raise your hand on the hand icon on the dashboard, and I can unmute your line. And Kevin, I have unmuted your line, but you're self-muted. Kevin Nunes.
Hi, I was just wondering when the 2021 SWEEP program is going to be open back up for grant applications.
Perfect, thank you, Kevin. Ame, would you like to respond to that?
Yeah, hi, thank you very much for that question, Kevin. We haven't received funding for the past fiscal year, so we don't have any funding, and one of the reasons is because the cap and trade revenues were lower than expected due to the economic downturn as a result of COVID. So we're waiting to see if that improves and looking for other funding opportunities as well. Thank you so much for the question.
Thank you, Ame. I greatly appreciate it. And at this time, Dirk, I don't see any other questions online. Perhaps what we should do is maybe get some closing thoughts from each of our representatives from maybe California and the Western Cape. I don't know, Carla, from our side, from California, if you're still on the line, would you like to provide kind of maybe some closing thoughts?
Sure. Just thanks again to everyone, and even in the retelling of the day zero events, it's still as gripping and challenging as ever. So I just want to say hats off to you all for handling that situation with just a tremendous amount of grace under pressure. I think there would be great value, at least from my perspective, in continuing conversations about ideas for collaboration, between governments at the federal, state, and local level, and ideas that you all may have in the Western Cape for how you engage with communities on what are very technical issues but affect everyone. Josh, I don't know the program, but that would be of great value to me to continue the dialogue, in particular on those kinds of topics as number one. And then also, one of the great challenges and opportunities about the climate discussion is the way in which that we can share ideas around modeling resources. And one of the things that we talk about in California is the granularity in the way in which we measure our systems, our climate and weather systems. And for example, Europe has much more refined kinds of modeling that they use. So I think to the extent that we can trade ideas, and California and DWR can learn a little bit more about what kinds of models are in use in the Western Cape to track and better understand extreme weather, I would be very interested in that kind of a discussion. Again, thank you all for such an informative morning. I appreciate it.
Perfect. And Carla, again, thank you so much. And I have to say, I think that this is definitely the beginning of our collaboration with the Western Cape and kind of furthering that work in regards to our communication, specifically on some of those key issues relating to both drought and kind of water use efficiency. I mean, again, this presentation really kind of reinforced the great similarities that are really happening on the ground between our two regions. With that, I'd like to turn over to my colleague Dirk with the Western Cape. Dirk, did you have some closing thoughts? And I don't know if you had another representative from the Western Cape that would like to provide some remarks as well.
From my side, I just see one of the hand of Francis Stein is raised. Can we perhaps give him an opportunity to pose a question?
Yes, let me see.
Francis, please proceed.
Yes, no, hello. Thank you very much. It was a lovely discussion. It was a lot of in-depth. The one question I have is I read a study, I think it was in California, in your catchment area, where a lot of your, what you call reservoirs, were decommissioned. And you were rather going for a strategy of developing wetlands. Is that still on track?
This is Carla. Janine, you may want to step in if you're still on the line. I think what that is referring to is some of the work that we have underway in removing dams, particularly in the northern part of the state, that are sort of no longer serving water and power interests. But by and large, I think the conversation in California around our reservoir strategies is kind of maybe threefold. One is, we do have an aging infrastructure problem like many places do. So how do we make sure that those reservoirs are safe? But two, how do we incorporate into that sort of this new modeling that we call forecast informed reservoir operations that make them work better in a climate world, both for flood and water supply. And then three, we are thinking about, since most of our water storage is in the form of snowpack, we are thinking about reinvesting in new storage. And I would say right now, the focus, because it's less expensive, but I would say we probably, don't quite have the information we need, but new investments are in many ways focused on, underground storage and investing in our aquifers and managing them more as dynamic water storage kinds of projects. And there are a couple of places, particularly in Northern California, where we are thinking about new above ground storage. So not decommissioning except in real specific locations where the use has, the value has diminished, and we see important benefits for some of our salmon species.
Thanks for that. From my side, perhaps, or from our side, just the final word. I think for me, this was really a fascinating event. And particularly to pick up on the emphasis you place on groundwater storage and groundwater replenishment. And on our side, we are putting a major effort in ecological infrastructure to make sure that the water becomes available and can be used. And there is a link between groundwater replacement and ecological infrastructure. But there are still a lot of questions from our side that we would like to have answered, particularly on groundwater replenishment and how to do that in our particular conditions. But that is a debate for a longer day, for another day. So I would like to agree that definitely there is scope for further discussion and further exploring of potential synergies. Thanks, Josh, also for you from your side for putting this together and arranging it. And it was really valuable from our side. Thanks, and over to you for the final word.
Perfect. Dirk, thank you so much, and thank you to all of our panelists and attendees. Again, this was a series of webinars that the Department of Food and Agriculture does in collaboration with our global partners, focusing on climate-smart agricultural issues. So everyone, thank you so much for your participation, and we look forward to further events in the future and for continuing dialogue. So thank you, everyone, and we look forward to seeing everyone again soon. Thank you.